Hello students, in this video we'll discuss Pascal's triangle and its relationship to the binomial coefficients and its relationship to combinations. So we recall that we have this object n choose k, which is n factorial over k factorial n minus k factorial, and this is a number of ways to select k elements, a subset of k elements from n. And in a previous video, we saw that n plus 1 choose k was n choose k, from n choose k plus n choose k minus 1. And what this relationship allows us to do is allows us to build up a recursion relationship. So what we'll do is we'll use that to build up a triangle. It's called Pascal's triangle. Pascal's triangle starts with a 1. Then underneath it, I have a 1 and a 1. And then, in further generations, what I do is I look above the previous 2. So I'm going to put a 2 over here, because 2 is the sum of 1 plus 1. And I'll put a 1 down over here and a 1 down over here. And now to fill in the next row, I look at the 2 above it. So I have a 1 and a 2. If I add those together, then I will have a 3. Similarly over here, I'll have a 3, and then a 1 and a 1. And I keep going. I have a 1, then a 4, then a 6, then a 4, then a 1, then a 1, then a 5, then a 10, then a 10, then a 5, then a 1. Let's do one more. We'll have a 1, then a 6, then a 15, then a 20, then a 15, then a 6, then a 1. And we can notice there's symmetry in this triangle. So over here we have a 4, over here we have a 4, right? Over here we have a 5, we have a 5, a 10, and a 10. We have a 6 and a 6, a 15, a 15, and a 20. So we can sort of see there's a symmetry going on, because we know there's a symmetry in Pascal's triangle as well, and these binomial coefficients, that n choose k is n choose n minus k. So these two relationships for combinations are reflected in this triangle. And the Pascal triangle is very useful. There's lots of relationships you can find from it, so we'll just focus on a few today. But one of the more important ones is that we're able to generate the binomial theorem from this triangle. So what happens is that the next row over here, so this is the first row, the second row, so this is, we'll call this the 0th row. It's the first row, second row, etc. And we see that in the nth row, what we have over here is we have, generally, we have n choose 0. Then we have n choose 1. Then we have n choose 2. Then we have all the way down to n choose n minus 1. And then n choose n. There's only one way to do that. So we see that the nth row of Pascal's triangle can be written with combinations. And we're also able to generate the binomial theorem, which says the following. It says that x plus y to the n is the sum, k goes from 0 to n, of n choose k, x to the k, y to the n minus k. And that may look daunting. However, if we think about it carefully, it's easy to figure out a combinatorial proof of this. So we write x plus y to the nth power as x plus y, x plus y, x plus y, x plus y, and there are n copies of this. So to figure out, I have to do all these FOILings out. But from each one of these factors, I will select either an x or a y. And the question becomes is, how do I get an x to the k and a y to the n minus k? Well, from these n factors, I had to select k x's. And by selecting k x's, I will have de facto selected n minus k y's. So this coefficient, if I add up all these coefficients over here, if I sum up all these coefficients, I exactly see that this binomial relationship is valid. So this is the binomial theorem. and it's easy to verify if you think about it combinatorially. So this is our binomial theorem. But now we see that the binomial theorem in Pascal's triangle basically take the two fundamental properties of these combinations and store them in a geometric shape, and also give us information about the binomial expansion of x plus y. So all these combinations have a very deep symmetry structure, have a very deep algebraic structure, and in this triangle there's many, many relationships. In particular, one relationship we can see is if I add up all the elements in the 0 row, I get 1. If I add up all the elements in the first row over here, I'm going to get a 2, then I'll get a 4, then over here I'll get a 8, then I'll get a 16. Then, so we can see over here, we'll have 5, 5, and 6 is 15. Then the next row will be 20, 30, 32. And so what we have over here is a particular consequence of this. Is if I plug in x equals 1, y equals 1, then 1 plus 1 to the n, or 2 to the n, is the sum, k goes from 0 to n, of n choose k. So we get all sorts of really beautiful relationships from either looking at the triangle or applying the binomial theorem to a special collection of x's and y's, and we get lots of useful information from this. Thank you very much.